Good morning. All right, so we are going to be doing a worksheet today about making equations of quadratics from different scenarios. I'll start easy, then I'll get hard. My little helper. All right, so first things first, find the equation of a quadratic that opens up. Key thing up from the following x-intercepts. So because it opens up and we know the x-intercepts, we know the solutions, right? So now this would just look like this. F of x equals x, this is a solution, so the opposite goes in here, x minus 4 and x plus 2. So because we know that 4 is a solution, we also know that negative 2 is a solution. What makes this 0? 4. What makes this 0? Negative 2. So to find the actual quadratic function, we carry out FOIL, and we get f of x equals x squared plus 2x minus 4x makes minus 2x minus 8. That is how you do that one, okay? Now the next question says, find the equation of a quadratic that opens down. Down means negative, so that means it's an upside down parabola, so that means it's negative. So in order to do this one, we do simply the same stuff here, but pay attention to details. Now it opens down, we know that this is going to be all negative when it's all done. X plus 3 and x minus 5. Just go one extra step. Let me make sure you guys can see all this. So now this just stays negative on the outside, and now you got to do all this work in here. So this will become x squared minus 5x plus 3x makes minus 2x minus 15. Last but not least, distribute this negative to every single term on the inside here. So your final function is f of x equals negative x squared plus 2x plus 15. That is how you do a couple of the first ones. And I'll be right back with a couple more. Okay, I'm going to do two examples. One with the first one's this, and then I'll be back with another example that looks like this, but worded differently. So now it says, find the equation of a quadratic from its vertex and a point. If the vertex is negative 4, negative 14, and the point is negative 2, comma negative 10, we've got to find out what this equation is. This we've been using for completing the square. This is called vertex form, where h and k are my vertex, okay? H and k are your vertex, h and k, these are the points, just so you guys know this. And what you're doing here is you're solving for a, because once you know what a is, you can then find out what all of this is, okay? So watch how I do this. This is our point. We know that this is our x and this is our f of x, or our y. It's always the output. So let's solve for a knowing all of this stuff. Here's how you do it. So I replace f of x with negative 10 equals, we're solving for a. If my point, my x, this x is right here, negative 2 minus 4, which is really, I put in the minus, so this would be minus negative 4 squared. Always make sure you're doing this and putting this in, so this is really plus 4, okay? Plus k, which is in this case minus 14, okay? Now I just carry out the work step by step. Negative 10 equals a times negative 2 plus 4 is 2 squared minus 14. I can go ahead and speed things up a little bit and bring this guy over here to the like terms. I'm going to add 14 to both sides, and I get 4 equals 2 squared is 4. I always put the number in front of the letter. So now this says 4 equals 4a. Solve for a. Here we go. 1 equals a. Okay? Now, I got to solve for this function. So I'm going to go back into this. I'm going to carry out all the work inside here. So when and you'll see what I mean by that in 1 second, so that I can then write this format into this. Watch how I do it. So now that we're not going to be using our points because now I know my a, okay, I go like this. F of x equals 1, because that's what my a is. X plus 4 squared minus 14, okay? And I go ahead and I do this work. F of x equals 1 times x plus 4 times x plus 4 minus 14, okay? And as I continue my work, I carry out FOIL, and this is equal to Well, 1 times all of this will just be whatever this product is, so we don't need this 1 anymore. But I'm doing that so you guys can see in case this number is not 1, you do this at the very end. All right, so I'll just do that for you. So this is all going to be x squared plus 8x plus 16 minus 14. Now again, if this was a 2, you would distribute the 2 to here, here, and here, but it's a 1, so we know this all stays the same. So now this says f of x equals x squared plus 8x plus 16 minus 14. Last but not least, combine your like terms, and I got f of x equals x squared plus 8x plus 2. So this is one example on how to find the equation when given the vertex and the point. Back in 1 second with another example. Okay, so here we go. Another example. And I know I changed the wording, but I want you to know that it means nothing different, okay? Find the equation of quadratic from its vertex and y-intercepts. Vertex is 1, -5, y-intercept is 0, 4. Well, guess what? I don't care that it says y-intercept. The y-intercept is still a point on that graph. So we can still use the exact same thinking we did on the last one, and we'll go from there. So, again, this is your h, this is your k, this is your x, this is your f of x, or your y as we know, okay? So again, exact same thinking. Don't let the words throw you off. So let's do it. -4 equals a 0 minus 1 squared. K is -5, so just do -5. And let's carry this out. -4 equals a times -1 squared minus 5. I can go ahead and speed things up. I'm going to add 5 to both sides. And I get 1 equals, -1 squared is 1, 1a. So now we know a equals 1. Okay, so now that we know a equals 1, now I'm going to go in and I'm going to solve my equation to write it in this format. So again, I do my f of x equals, we know a is 1. I'm sorry, we go back into this. So I know this is 1 times x minus 1 squared minus 5. I carry out this work. F of x equals 1 times x minus 1 times x minus 1 minus 5. F of x equals, I'm just following the format so I don't mess up. X times x is x squared. Negative x makes -2x plus 1 minus 5. And again, if this was a 2 or a 3 or a -5 or whatever, I would distribute that across every term inside here, but it's a 1, so we know this just stays as such. And then this says f of x equals x squared minus 2x plus 1 minus 5. And this is all she wrote. X squared minus 2x minus 4. This is the equation from here, and I can see my y-intercept is true, -4, -4. Okay, so that's that. A couple more. Okay, now this might look familiar. We did this last week. I'm going to start easy. Then I'm going to do another example going into hard, which is all the systems of 3 equations, why it means so much to us. Now, this one's easy because I already know my C, all right? And I'm going to set up a systems of 3 equations in order to figure out what this equation is because I got 3 points, 3 variables. Let's figure it out. So here's how you would do it. And again, I'm starting easy, going hard. I already know the C is 3 because of this, but it's just follow the same process every single time. So here we go. When x is 0, y is 3. So 3 equals a times 0 squared plus b times 0 plus c. So essentially 3 equals 0 plus c. C is what? 3 equals c. Then on another one, I got 2, f of x, or the y is 2 and the x is 1. So 2 equals a times 1 squared plus b times 1. We already know c is 3. Go ahead and put that in there. Plus 3. Carry this out. 2 equals 1 squared is 1. This is a plus b plus 3. Let's make our life simple. Subtract 3. So -1 equals a plus b. I'm going to use this. I use this within here, and you'll see why this is important. And then last but not least, I got one more to go. I got this one right here. Y is 3 when x is 2. So 3 equals a times 2 squared plus b times 2 plus, we already know our c is 3. Okay? So put that in there when you already know it. So this is 3 equals 4a plus 2b plus 3. Subtract 3 from both sides, so 0 equals 4a plus 2b. We got to use this because now we got a nice systems of equations. And when I have a systems of equations, this makes life a lot easier. So I got these two right here, and I'm going to put these off up here. So this is -1 equals a plus b, okay? I got 0 equals 4a plus 2b. Well, I think the easiest thing to do is multiply this top by -2 to cancel off my b's, and I'll put that answer right beneath it. So I'm going to have 2 equals -2a minus 2b. Add these up. 2 equals 2a, so a equals 1. A equals 1, we know c equals 3. Let's solve for b. I'll use this one. Smaller numbers, a little easier. So now this is -1 equals 1 plus b. Minus 1 from both sides, so -2 equals b. So what's the equation of this quadratic? I'll do it right over here, down here so you can see it. Obviously we know our a is 1, so this is f of x equals x squared minus 2x plus 3. That is how you do that one. Now we did this last week, but now I'm going to be back in 1 second with one more example to show you how we tie together what we've been doing this week. Okay, so we're back. Now it's a little more difficult because now we don't know the y-intercept. We don't know the c. So now this is why all this stuff we've been doing this week on systems of 3 equations comes together, and it's important that we take our time, pay attention. So again, we know that our standard form of our quadratic is ax squared plus bx plus c. Let's set up 3 equations with our 3 points. When x is 1, our y is 3. So 3 equals a times 1 squared plus b times 1 plus c. So 3 equals a plus b plus c. This will be crucial. Next one. 9 equals a times 4 squared plus b times 4 plus c. So 9 equals 16a plus 4b plus c. Again, this is crucial. Coming forward in just a minute. Last but not least, 1 equals a times 2 squared plus b times 2 plus c. 1 equals 4a plus 2b plus c. Hello. You want to do some quadratics with Daddy? Yeah. All right, let's see if we can do this. All right.
This take a lot?
Something like, yeah, exactly. Good job. So now I got over here, I'm going to organize myself. I got 3 equals a plus b plus c. 9 equals 16a plus 4b plus c. And 1 equals, yeah, baby, 4a plus 2b plus c. 1 second. Okay, sorry about that. So here we go. Now that I got my thing set up, now again I want to look at my problem. Which letters look the easiest to eliminate? I'm going to say my C's because they all have a coefficient of +1. First things first, I'm going to take these two right here at the bottom. I'm just literally going to do this minus this right beneath it. And I can do that instead of adding them because that means I'm really subtracting -1, -4, -2. So essentially, I'm multiplying this whole thing by -1, okay, or just subtracting. So when I do that, 9 minus 1, which is 8, equals 16 minus 4, which is 12a, 4 minus 2, which is plus 2b. This is one situation. And then I'm also going to do 3 minus this one as well. So when I do that, I'm going to get, oops, 1 second. I'm going to take, so now that I use these two, I'm going to now use these two. And what I'm going to do is I'm going to multiply this guy by -1 so that I can use it. So now this says -3 equals -a minus b minus c. And then I got 9 equals 16a plus 4b plus c. When I add these up, I get 6 equals 15a plus 3b. These cancel. So now I got these systems of equations. 15a plus 3b. All right. So what is going to be the easiest here to cancel off? I see that it's probably best that I multiply the top by -3, the bottom by -2, so that I can cancel these off. Just to cancel the b's off. So when I do that, I get -3 times -2. I'm sorry, -3 and just +2. My apologies. And then I get -24 equals -36a minus 6b. Then I get 2. I get 12 equals 30a plus 6b. Add these up, I get -12 equals -6a. I divide both sides by -6, and I get 2 equals a. 2 equals a. Let's go right into here to solve for b. Okay, I'm just choosing this one randomly. 6 equals 15 times 2 is 30 plus 3b minus 30 minus 30. I get -24 equals 3b. I divide both sides by 3. I get -8 equals b. This should look very familiar. Now let's solve for c. I'll use this equation up here because that requires the least. So 3 equals, can you see this? Probably not. Let me scroll down. 3 equals a is 2, b is -8 plus c. So 3 equals -6 plus c. Add 6 to both sides. So 9 equals c. Our final equation is f of x equals 2x squared minus 8x plus 9. That is how you do one like that. You'll see that in today's work, and I will see you guys in today's Google Meets.